So let us continue with the fourth session of vector algebra. We have defined addition, scalar multiplication, and scalar product, which we call the dot product of two vectors. Okay, let us take the question. Prove that points A, B, and C, whose coordinates are -2, 3, 5, 1, 2, 3, and 7, 0, -1, are collinear points. Remember, points A, B, C are collinear points. Well, when can you say the points A, B, C are collinear? If you have vectors A, B, and B, C are collinear vectors. See, simply two vectors are collinear doesn't mean all points on that vectors are collinear. But here there are two vectors A, B, and B, C in which one point is common. That is the point here. There are two vectors AB and BC in which one point is common. If AB and BC are collinear vectors where B is a common point, then points ABC are collinear points. Okay? Either we can say AB and AC or BC and AC. It makes no difference. So you are given with points A, B, and C. How do you find vector AB? AB is equal to, we know that AB is equal to OB minus OA, or position vector of terminal minus position vector of initial. Okay, so OB minus OA. When A is at -2, 3, 5, what is the vector OA? OA will be -2i plus 3j plus 5k. And B is at 1, 2, 3. What is vector OB? OB will be I plus 2j plus 3k. If P is at xyz, then vector OP is xi plus yj plus zk. So now it is obvious OB minus OA, that is calculated. And further vector BC is calculated in the same way. That is, when you calculate BC, OC minus OB, we are getting 6i minus 2j minus 4k. That is 2 into, which is nothing but AB. So BC equal to 2AB. Now when BC equal to 2AB, vector AB and BC are collinear vectors. When AB and BC are collinear vectors, the points ABC are collinear points. Well, if alpha, remember vector alpha equal to 3i minus j, and vector beta 2i plus j minus 3k, express beta as beta 1 plus beta 2. Remember, the vector beta I to represent as sum of two vectors beta 1 and beta 2, where beta 1 is parallel to vector alpha and beta 2 is perpendicular to the vector alpha. So what we need is that it is given with alpha and beta. Beta 1 is parallel to alpha. We want beta 1 parallel to alpha. So I can say beta 1 equal to lambda into alpha. So for some real values of lambda. So we can write beta 1 equal to lambda into alpha. Alpha is 3i minus j. Right? That is 3 lambda I minus lambda j. And beta will be beta 1 plus beta 2. So what will be beta 2? Beta 2 will be beta minus beta 1. Beta is already given 2i plus j minus 3k minus beta 1 we assumed 3 lambda I minus lambda j. So this will be 2 minus 3 lambda I plus 1 plus lambda j minus 3k. Now it is given that beta 2 is perpendicular to alpha, or beta 2 dot alpha will be 0. Beta 2 dot alpha will be 0. You know, two vectors are perpendicular when their dot product is 0. Now we know the dot product of beta and alpha, that is alpha is here, 3i minus j, and beta 2 is here, beta 2. Their dot product, that is 2 minus 3i into 3 plus 1 plus lambda into minus 1 plus minus 3k into 0. Minus 3 into 0. So 2 minus 3 lambda into 3 plus 1 plus lambda into minus 1 minus 3 into 0. From here we are getting lambda. Lambda equal to 1 by 2. Putting the value of lambda in this, we get beta 1. Putting the value of lambda here, we get beta 2. Beta 1 and beta 2 we get, and that is beta is written as beta 1 plus beta 2. Okay, beta is written as beta 1 plus beta 2. Now, if theta is angle between two unit vectors A and B, prove that sine theta by 2 is half magnitude of A minus B. Theta is the angle between two unit vectors A and B. Prove that sine theta by 2 equal to half into magnitude of A minus B. Given A and B are unit vectors, now magnitude of A minus B squared, we know it is magnitude A squared plus magnitude B squared minus twice, twice A dot B. Magnitude A is given to you, 1, magnitude B is given to you. So A dot B is substituted as magnitude A magnitude B cos theta. A dot B is written as magnitude A magnitude B cos theta. So 1 plus 1 minus 2 into 1 cos theta. That is 2 minus 2 cos theta, or 2 into 1 minus cos theta. Now you remember 1 minus cos theta is 2 sine squared theta by 2. So here we have sine squared theta by 2 is 1 by 4 into magnitude of A minus B squared, or sine theta by 2 is half into magnitude of A minus B. It's clear? For any two vectors A and B, prove that modulus, see A dot B is a number, modulus of A dot B less than or equal to magnitude A magnitude B. Modulus of A dot B less than or equal to magnitude A magnitude B. It's simple. If A equal to 0 or B equal to 0, the result is obvious because both the sides are zeros. If, and I suppose now A and B are both non-zero. Now what is A dot B? Magnitude A magnitude B cos theta. Correct? So A dot B, modulus of A dot B is magnitude A magnitude B cos theta. Now what we know is that cos theta is between minus 1 and 1. So mod cos theta is between 0 and 1. And if I multiply both sides with mod A magnitude A magnitude B, mod cos theta, I am talking about here, cos mod cos theta less than or equal to 1, multiplying both sides with magnitude A magnitude B, you get magnitude A magnitude B cos theta less than or equal to magnitude A magnitude B. So that's all, magnitude A magnitude B cos theta less than or equal to magnitude A magnitude B. And this result is known as Schwarz inequality, or Cauchy-Schwarz inequality, or simply Schwarz inequality. Schwarz inequality. Okay? Modulus A dot B less than or equal to magnitude A magnitude B. Further, for any two vectors A and B, prove that magnitude of A plus B less than or equal to magnitude A plus magnitude B. In real number modulus, we know modulus of A plus B less than or equal to mod A plus mod B. The same thing here. If A equal to 0 or B equal to 0, the result is obvious because both the sides becomes equal. Equality holds. I suppose A and B are both non-zero numbers, vectors. Magnitude of A plus B squared, you know it is magnitude A squared plus magnitude B squared plus twice A dot B. Now, twice A dot B. See, A dot B is a number. Any number cannot exceed its modulus. So, twice A dot B less than or equal to twice modulus of A dot B. And modulus of A dot B is less than or equal to magnitude A magnitude B. So, what we can replace is that twice A dot B, I can write less than or equal to twice magnitude A magnitude B. So, the equation 1 will be replaced as an inequation magnitude of A plus B squared less than or equal to magnitude A squared plus magnitude B squared plus twice magnitude A magnitude B, which is nothing but magnitude A plus magnitude B squared. And taking the square root, we have magnitude of A plus B less than or equal to magnitude A plus magnitude B. This inequality is known as triangular inequality. Okay. Now we come to the second major point, that is a cross product or vector product of two vectors. We define for non-zero vectors A and B. For two non-zero vectors A and B, we denote the cross product, correct? Vector product or cross product denoted by A cross B. It is defined as A cross B equal to, it is a vector, remember, magnitude A into magnitude B into sine theta into n cap. Remember, magnitude A is a number, magnitude B is number, sine theta is again a number, n cap is a unit vector, where theta is angle between A and B, and n cap, theta will be between 0 and pi. N cap is a unit vector perpendicular to both A and B, perpendicular to both A and B, such that A, B, and N form a right-handed system. Very important. A, B, N form a right-handed system. Right-handed screw is rotated from A to B. When a right-handed screw is rotated from A to B, the tip of the screw moves in the direction of it. When a right-handed screw is rotated from A to B, the tip will move in the direction of N cap. So that is the direction of N cap. Now, if A or B, one of them is 0 or both are 0, then we simply define A cross B as a 0 vector. A cross B we define as a 0 vector. Suppose here is A, here is B. When A cross B is defined, it will be moving in that direction, N. If it is B cross A, it will go in the other direction. Minus N will be in that direction, minus N will be in the other direction. When the screw is rotated from A to B, the tip of the screw will be moving in the direction of N. Properties of vector product. A cross B, first of all, is a vector. A cross B will be minus B cross A. A cross B is perpendicular to both A as well as B. That means A cross B is perpendicular to the plane containing A and B. Why A cross B is perpendicular to A? Because the direction of A cross B is N cap. The others are numbers. And N cap is perpendicular to both A and B. If theta equal to 0 or theta equal to pi, sine theta will be 0. That means A cross B is a 0 vector. A cross B equal to 0 implies either theta equal to 0 or theta equal to pi, or one other vector is a 0 vector. That means either A equal to 0 or B equal to 0 or theta equal to 0 or pi. Correct? A cross A will be 0 vector because angle between A and A is 0. A cross minus A is also 0 vector. And if theta is pi by 2, A cross magnitude of A cross B is magnitude A into magnitude B into sine pi by 2. That is simply magnitude A magnitude B, because N cap is a unit vector. Correct? N cap is a unit vector. A cross B plus C. Distributive below is there. A cross B plus A cross C. Lambda can move with A or B or even come out. Okay, lambda into A cross B. Sine theta will be magnitude of A cross B upon magnitude A magnitude B. This theta will give only the acute angle. Okay. A unit vector perpendicular to both A and B is the unit vector in the direction of A cross B. It will be A cross B upon magnitude of A cross B. I cross I is 0, J cross J is 0, K cross K is 0, K vector K. K cross K is 0. Okay. Whereas I cross J is K, because magnitude I into magnitude J into sine theta into vector perpendicular to I and J, that is K vector K. Okay. I cross J is K, J cross K is I, and K cross I is vector K. K cross I is J, and I cross J cross I is minus K, K cross J is minus I cross K is minus J. You don't need to worry about it. You can remember like this: I, J, and K. You can see I cross J is K, J cross K, J cross K, J cross K is I, and K cross I is J. You remember in that cycle, I cross J is K, J cross K is I, K cross I is J. Whereas if we change the cycle, it becomes negative. That means I cross K will be minus J, K cross J will be minus I, J cross I will be minus K. You have to remember, immediate remembering is done from the circle and cycle. If A equal to A1I plus A2J plus A3K, B equal to B1I plus B2J plus B3K, then A cross B. You can easily observe this is simply a value of the determinant. First row is I cap, J cap, K cap. Second row is A1 into A3. Third row is B1, B2. You can evaluate, that will be I cap into A2 B3 minus A3 B2 minus J cap into A1 B3 minus A3 B1 plus K cap into A1 B2 minus A2 B1. So this you remember, dot product of A and B is A1 B1 plus A2 B2 plus A3 B3, whereas cross product will be determinant. First row is I cap, J cap, K cap. Second row is A1 A2 A3, and third row is B1 B2 B3. Evaluation is the cross product. Take an example: A and B are given vectors. what is A cross B, what is its magnitude, and find a unit vector perpendicular to both A and B. What is A cross B? It is the determinant. First row is I cap, j cap, k cap. 213 from A, 213, and 35 minus 2 from B. And that is evaluated as 79 plus 30 minus 79 plus 13j plus 7k, and its magnitude will be under root minus 17 squared plus 13 squared plus 7 squared. That will be nothing but root 507. Okay, and magnitude of A cross B. None. Okay, unit vector perpendicular to both A and B. It will be A cross B upon magnitude of A cross B, because A cross B is a vector perpendicular to both A and B. If you want a unit vector, divide with its magnitude. So you have a unit vector perpendicular to both A and B. You have a few questions. I'll be sending this. Now you can just take a shot of these questions. Okay. Few questions only, very simple questions. You can, all the questions are of the same kind which we discussed. We'll meet back tomorrow with more. Okay.